Can Claude Code train a small image open source model to be able to accurately identify and classify animals just based on photographs? On today's video, that's exactly what I'm going to be exploring as I try to get Claude Code to train an open source image model in accurately identifying an animal. This could be the same technology that is used in camera traps all over the globe in accurately identifying and tracking wildlife. So it's super important if Claude Code can actually get a step in the right direction to getting this right. So without further ado, let's get into it. Now, by no means am I an expert in open source image models or small image models. This is really basic knowledge, and what I'm going to be going through is very basic at its most fundamental roots. So we're going to keep things nice and simple. I'm going to start by coming on to pytorch.org, where it's going to have the library of the accessible open source image models that we're going to choose from. So all we're going to do is type in ResNet. This is the image model that we're actually going to use. Okay, when that's come through, you're going to want to choose something like this. And it's going to bring you to a page similar to this. Now, this is, I believe, a description of the model. And the way I put it, if you scroll down here, is there's different subcategories of models, different layers of models. And the lower layers are the kind of lighter, lower weight models that we'll be using in this case, the Res 18. And then there's the higher layered models, the heavier ones, ResNet 152, ResNet 101. We won't be using these ones because it's not really feasible for the project we're in, but they have much more training data. And as you can see here, if they're asked a question with one answer attempt, this is the percentage chance they'll get it wrong. So 30% of the time, on average, ResNet 18 will get an image recognition question wrong. As you can see here, if they're given 5 chances, they will obviously have a lower error rate or error chance. Now, this isn't truly indicative to say it's definitively wrong 30% or 26% of the time. It's just kind of this error prediction. If that looks complicated, I absolutely understand you. It looks really complicated to me too, but the good thing is we have super intelligence in Claude Code. It's going to be able to do all of that, setting up that model, fine-tuning it absolutely by itself. We just need to have kind of a sort of a top-down level understanding of the entire process. And the big thing as well is we're going to be supplying Claude Code with a folder of images, so it can sort that into different species, training data and test data as well. So it will be able to train the model and then test it. So we're going to be able to see if it is truly accurate in its ability to identify an animal based on any image of that same species. And that is exactly what this prompt is going to get Claude Code to do. Is just going to get it to set up the project, train the 18 layered model to be able to identify its these 6 species that we give it, and obviously test it on the data and train on the data as well. And as you can see at the bottom, I just added in a small line saying what the output should be, a rough app, very simple UI, where I could just add in a picture of any one of the species and the model will be able to predict or guess percentage-wise what it actually is. Okay, to get our training data for the model, all we're going to do is come over to this website called Kaggle. It's got loads of data sets for training AI models, but we're going to be really specific here to only get the one we want. In this case, you're going to search up animal image classification. So there's a bunch of search results that comes up here, but all we're going to do is narrow it down to the datasets option. Really simple. It's in the header here. And now this is going to give us the image datasets from which these AI models are trained on. Now there's plenty of image datasets to go around, but what I often find is that most of these are very simple. Maybe they're 5 to 10 species, but the species are very different. So it might be a dog, cat, and a bison. Obviously, biologically, they're similar, but visually, they look very distinct. So what I'm going to do instead is going to click on this one here, image classification, 64 classes animal. This gives us 64 different species to work with. We won't be using them all because it's just too much for Claude Code to handle, just a bit too overkill. But what we are going to do is we're going to look at this list. We can narrow it down to maybe 5 to 8 species that look very similar. So it's going to be more challenging for the model to differentiate them. So by going through this, maybe, we have snake and squid. We could give it an image of a squid arm and just a random part of a snake. Maybe it might confuse it there. Or there's wolf and dog, whale, walrus, penguin, peacock, or just animals that look a lot similar or more similar that might trip the model up. I'm just going to click on download here and download dataset as zip. Claude can unzip it for us, and we can just get it to maybe narrow down the amount of species that we're going to choose. Okay, and while it is downloading slowly there, we could just look through some of the animals and actually decide ourselves maybe what maybe 5 to 10 animals we're going to choose. And I think the best bet here is probably to go for all big cats or canids, so hyenas, wolves, dog. This is so that if it kind of gave a random body part, maybe just the hind legs or the tail, it might be a bit more difficult to differentiate. Okay, so I've gone and added all those image files into the project folder and also updated Claude's main prompt. So I've essentially told it not to ask me for a set folder structure. I'm just going to let it do that work there. And also giving it more information on what I just told you guys in so far as getting the right species out. So big cats and canids, species that look morphologically very similar, so it's going to be much harder for the model to get it right each time. And finally, just a really important point that I've told Claude is to set aside 2 images per species that is not going to be in the test or training data that I can give the model or the UI that's going to be building for me to test it myself. This is really important to emphasize, because if it is trained on those images, it's obviously going to get them right, whereas if it's completely new, it's going to be a lot harder. So yeah, that looks all good. Claude's going to choose those species, going to go and unzip those files and get rid of the ones we don't need, and yeah, prompt looks good to go. So we're going to send that off and see what Claude can actually come back with. Okay, so Claude Code has come back here with the output, and it looks absolutely great. However, there was something really important that it raised, and I'm glad it raised it, as I should have thought about this before myself as well. And that is that the images that we fed it were actually extremely polished. So polished to the extent that I think they're probably AI generated images. They're really good, really clean. But what this does is essentially makes it so easy for the model to distinguish what the animal is. If we are feeding those test images to it, which we've compiled, it's going to be extremely easy to tell what the animal is. There's no challenge at all. Claude proposed a fix, which I implemented along the way, as you can see here. And that fix was for Claude just to darken, to roughen up the images, to make them seem like they've come out of a real life camera trap, which is what these images are actually taken from in the wild. This is what the AI is actually supposed to do, is be trained on camera trap images, which are not going to be clean, which are not going to be polished. So Claude's done 2 separate things for me there. It's gone ahead and set aside new test images in UI demo hard over here, which are images that have been roughened up, look like they're from a camera trap, but it has also applied that same design, camera trap design, to other test images, and it has given those test images back to the model and retrained it on camera trap images. And from brief snippets of the conversation, it seems that the model's accuracy has gone sky high in terms of being able to identify an animal in a camera trap. So let's go ahead and take an image. This is one of a cat, as we can see here. Darker images, cheetah, dog, hyena. Okay, this is a nice one of a hyena. So we'll put this image into the classifier. So this is the UI here. And we're going to drop that image of a cheetah into it, and we are going to submit this. And boom, got it right. So the first attempt is the model actually getting it wrong. Very interesting. Now, I will say in its defense, it is a weird looking hyena. But anyway, that's in the hyena folder, and it's gone for a jaguar, not even listed hyena. Now that is a weird, maybe if we were to give it this image here of this hyena. So go back here and submit this 99% hyena. So it's interesting. It's gotten that wrong, right. I don't think it's sorted the images wrong, but it's just interesting to see. Okay, let's try a lynx. Oh, okay, so pretty close actually. Lynx at 30% chance, and cat is a 28% chance. Wolf will be interesting. Okay, wow. Dog, 62% chance. Wolf is 29% chance. Very interesting. Okay, so we can clearly see the model is struggling with these more grainy, tougher to break down images. And maybe this is where the 18-layer ResNet model struggles a bit more in comparison to the heavier models. And this, you can kind of see the class coming into play. Although obviously we're not comparing the heavier models, but you might wonder what that difference might look like. This example is just really fun, really light. It's just really interesting to see what the AI can do, what Claude can do more so, how it's so easy for you to just pick a data set, pick a model that Claude can expand upon, train itself, and just really shows you where the future of this technology is going. It's so obvious to see. But anyway, thank you so much for watching. I hope you enjoyed this fun little video, and I'll see you in the next one.